Now let's take a look at some data transformation functions. Even when our data are tidy, we still might need to wrangle it in order to answer our research questions. This could include subsetting the data, creating new variables, renaming variables, reordering observations, or collapsing to a statistical summary. Let's take a look at some examples and use some of the functions in the tidyverse in these examples. I'm going to use the flights data, and I notice that I, again, had not inserted the correct location for these data. Now I have. I'm going to go ahead and clear out everything I have so far because the flights data is pretty big. Let's go ahead and read in the flights data. So we've done it, 28 megabytes worth of data. Let's remind ourselves by looking at a tibble of what kind of size data set. So it's 19 variables, 336,776 rows. Let's obtain the flights from the 4th of July. We can use the filter function. So we're going to ask for July 4 flights to be filtered, flights, month equals 7, day equals 4. And now if I look at July 4 flights in my environment window, I see that there are 737 flights on the 4th of July in New York City. We still, of course, have those 19 variables. A nice feature of the tidyverse is that if we want to save our data, but also look at the first part of it, we can do that all in one step. So instead of having to do this, what I'm doing right now, which is looking at the first part of the data with July 4 flights, I'm going to give the exact same command, but enclose it in parentheses. Let me go ahead and clear out this console window so you can watch this. So I'm going to put this in parentheses, run this, and notice it created. I should have cleared the environment too. Let me do that too. All right, now everything's cleared. So I need to read in the flights, but now I'm going to go down here and do this. And now we've created July 4 flights, and we also had a chance to look at it at the same time. Saving separate data sets becomes less important in the tidyverse due to our ability to pipe. For example, let's suppose I want to see if there's a relationship between the distance of a flight and delays in the flight for flights on the 4th of July. So look what I'm doing here. Normally what we would say is you better pull out all the July 4th flights and then you can make your plot. But because we have the piping capability, this little script kind of makes it not necessary to save out those separate flights. I'm going to take flights, I'm going to pipe them to the filter, which will then filter out down to the July 4th flight. Then I'm going to pipe that to the ggplot function, and we're going to go ahead and look at a scatter plot where distance is on the x-axis and departure delay is on the y-axis. Now, one thing to point out, and this one's easy to get confused by, once you switch to ggplot, remember you have to have a plus at the end of every line. I have seen a comment by Hadley Wickham that he said maybe in a future update he'll make it so you can use either a plus or a pipe, which would kind of make it all consistent, wouldn't it? You'd be filtering down to the ggplot, filtering that to GeomePoint, filtering that to labs. On the other hand, I can see the rationale of the plus because it's not just piping, it's layering all the aspects we have here. Okay, enough philosophizing. Let's actually run this thing. So I'm going to open this window a little bit bigger so we can see what happens. And there we go. Notice it told us as a warning that it had missing values for either distance of the flight or the delay in the flight on 3 rows, so it took those out automatically. So here's our little graph to show the delay based upon distance of the flight. And what can we tell from there? Well, it looks like once we get beyond 2,500 miles, there's not much delays. But for anything that's smaller, it looks like these down here with small distances seem to have a little bit more delays. We can use logical operators for many possibilities. Here, for instance, I'm going to use the in operator to capture the first and second months. So here you can see it's month 1, and if we look down, we'd see 51,955 January and February flights. Here I'm going to obtain all flights delayed by more than 8 hours on either the arrival or departure. Notice the relational operator, greater than 480 for delay, greater than 480 for arrival. So that's more than 8 hours. And there were 71 of those. I'm curious whether this is associated with certain destinations. So look what I'm doing here. I'm filtering based upon those 8 hours of either departure or arrival, and then I'm making a bar graph. So let's open this up a little wider so the graph will show up. Okay, that's a little bit tough. But we can still see, oh, look at this. Flights to Atlanta happen to have the biggest count, most bars there. Let's make this a little bit easier to read. And here I'm not doing anything with the transformation function of filter. I'm messing around a little bit with the theme and the axis angle for my bar. See what I've done? I've put the destination now on a vertical. Note that the filter excludes both false and missing observations. If you want to include missing observations, you need to explicitly ask for them. Let's see how many flights are in the data set where the tail number is unknown. So look what I'm doing now. Filtering on is.na, meaning is it missing tail number. There were 2,512 flights with missing tail numbers in the data set. We can rearrange data with the arrange function. Suppose we want to arrange data by departure delays. So here I'm creating flights arranged by departure delays. And so if you look at departure delays here, it starts with the smallest number, which is actually leaving 43 minutes early, and then that data set will work all the way up to the longest delay. We might want to focus on the worst delay problems. So in this case, we could arrange in descending order. So I'm using arrange and DESC for descending to give it in descending order. And so we see at the top is 1,301 minutes. That's quite a delay. And then it goes down from there. And if we wanted to, we could focus on the top part of our data set to look at the worst delays. Note that if there are any missing values for the variable we're sorting on, these cases will be put at the end of the data set. If we want to sort on multiple variables, we can do so. For example, this command will sort by month, but for equal values of the month, it will then sort on departure delays. So this will give us departure delays by month. So we'll see all the flights, but then it will be sorted by month and then by departure delay. So here you see that the month is January And here you see that we did descending order of delays within the month of January. I'm going to go ahead and stop there, and I'll meet you for some more data transformation functions in the next part.